we have functional group, and we have what we call homologous series. Okay, this functional group, okay, is the one that indicates the name of the family of the what of a particular organic compound. If you have single bond, okay, it's a functional group for this family. If you have double bond, it's a what? The functional group for this family. If you have triple bond, it's a what? Functional group for this particular what? Family, which is what? Alkyne, alkane, and what? Alkane. Each of these family name or each of these functional groups, okay, has general formula, which is this. For alkane, CnH2n plus 2. For alkane, they have a general formula, which is what? CnH2n. And alkyne also has what? General formula, which is what? CnH2n minus 2. Okay? And I made you to understand that this N, okay, is the one that is dictating the name. The one that is dictating the name of each members in this group. For alkane, you have the first member to be methane. Okay? Because this N is equal to 1. The second member is what? Ethane. Okay? The third member is what? Propane. All of them carry A because their family name is carrying A. Okay, so the next member is what? Butane. The next member is what? Pentane. Okay, and that is how it goes like that up to the K for first 10 members. Now, you see this methane, if you want to draw the structural formula of methane, you want to draw the structural formula of methane. Okay? There's one thing that you should keep in mind. What you should keep in mind, let me shift this. What you should keep in mind is that for any alkane, you have single bond. Single bond between carbon to carbon atom. Okay, single bond between carbon to carbon atom. Between this carbon and between this carbon, you just want one bond. And you have to still take into consideration the tetravalency property of carbon. Because this carbon, okay, because of the tetravalency, it has this ability of bonding with different atoms. Okay? And when it's bonding with different atoms, it has this ability of what? Of being surrounded by what? By four bonds. Okay, this carbon now can be surrounded by 4 bonds. 1, 2, 3, 4. This one too can be surrounded by 4 bonds. 1, 2, 3, 4. Okay, now, but this one is a case of what? Ethane, because of two carbons. But what if in the case of methane, you have carbon being surrounded by hydrogen, 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 and hydrogen. This is an example of what? Methane. Okay? Because the structural formula of methane, the molecular formula of methane is gotten from this formula, which is C, methane is 1. N equal to 1, you put your 1, or you not put it. C8, 2 times 1, 2. 2 plus 2, 4. You have C8,4. Now, this C8,4 now, this is its structural formula. So, if you want to draw for ethane, at least you need 2 carbons. From here, you have what? N to be equal to what? 2. You have C2, 8, 2 times 2, 4. 4 plus 2, 6. You have what? C2, 8, 6. And it is what? Ethane. Don't forget this ethane. What makes it to be ethane is that it has what? Single bond between carbon to carbon atom, or between carbon to hydrogen atom. So you have what? Single bond. Now, if you want to draw the structural formula of this ethane, this is 2 carbon. Okay, between carbon to carbon, you have what? Single bond. Now, this carbon will be surrounded by what? 3 hydrogen. So that there are 4 bonds surrounding the what? The carbon. This one too, we have hydrogen here hydrogen here, hydrogen here. In such a way that there are what? 4 bonds surrounding this carbon. 1, 2, 3, 4. Are you getting it now? So if you count the number of hydrogen that you have here, is what? 1, 2, 3, 4, 5, 6. Which is this 6 hydrogen. Count the number of carbon that you have here is what? 2. 1, 2. And that is making it to what? C2H6. Now this is the molecular formula of what? Of alkane, and this is the structural formula of what? Alkane. Now let's pick another member of what? Of alkane. Let's pick butane. Butane. Now butane means N equal to what? N equal to 4. Butane means N equal to what? N equal to 4. You substitute inside this formula. What do you have? You have C4, 8, 2 times 4, 8. 2 times 4, 8. 8 plus 2 will give you what? 10. C4, 8, 10. This C4, 8, 10 is the what? Is the molecular what? Molecular formula. Now, if you want to draw the structural formula of this, what will it be? 4 carbon. This is what? 4 carbons. And we have to keep in mind that this 4 carbon is separated by what? Single bond. Why? Because it's a member of what? N family. That is what? Alkane. Are you getting it now? Yes, alkane. Which is coming from where? From butane. A. Okay? That means everything is what? Single bond. Now, how many hydrogen do you need? 10 hydrogen to surround all the carbons. Okay? And when you are distributing this hydrogen, you have to make sure that each of the carbon is surrounded by how many bonds? 4 bonds, not more than 4. Okay? Now, here now you have what? Hydrogen. Here now you have what? Hydrogen. Here now you have what? Hydrogen. In such a way that you have how many bonds surrounding the carbon? 4. 1, 2, 3, 4. Here too, you do the same thing. Hydrogen, hydrogen. How many hydrogen do you have? You have 2. But how many bonds do you have? You have what? 4 bonds. The same thing here. Hydrogen, hydrogen. 1, 2, 3, 4. You still have what? 4 bonds. But you have how many hydrogen? 2 hydrogen. The same thing here. Hydrogen, hydrogen, hydrogen. You have 3 hydrogen here. But how many bonds? 1, 2, 3, 4. You have what? 4 bonds. That is for what? That is for butane. All these ones that we are doing, they are for what? Alkane family. They are what? Alkane family. Now, what if we are now doing alkane family? Please be jotting. Now, what if it is now alkane family? Okay? Alkane. Okay, what made this thing to be alkane? This ENE is because of what? Double bonds. If you have, that means between carbon to carbon atom, you must have what? 2 bonds. Okay? Between carbon to what? To carbon atom. So meaning that, okay, the first member is what? Under alkane, the first member is what? 18. Starting from N equal to 2. Is what? 18. Meaning that N is equal to what? 2 in this formula, which is what? CnH2n. So if you substitute your N to be equal to 2, what do you have? You have C2H what? 2 times 2, 4. C2H4. Meaning that for 18, under alkene family, the molecular formula is what? C2H4. This is the molecular formula for what? For 18. Now, how do we draw the structural formula for 18? As we have been doing for what? Under alkane. How do you draw the structural formula of alkene family? Now, this is what we are going to do. How many carbon do you have? 2. You have what? 2. Carbon to carbon. But at least must have what? Double bond between carbon to carbon. Because this is what is making them to be what? Alkane. This is what is making them to be what? Alkane. Are you getting it now? Now, the remaining hydrogen now, which is now 4, you now distribute it. When you are distributing it, you have to make sure that each carbon is surrounded by how many bonds? 4. 4. Okay? This one now, we have hydrogen. This one now, we have hydrogen. How many bonds is surrounding carbon here? 1, 2, 3, 4. For this particular one. Then you can't put anything again. You can't put anything here again. Because if you put here now, it will be what? It will be 5. So that means it's violating tetravalency property of what? Of carbon. So here, it will be like this. The same thing is here. How many bonds do you have here? 1, 2, 3, 4. That is what? 4 bonds. Then you cannot complete it with what? Hydrogen. Okay? How many hydrogen do you have in total? 1, 2, 3, 4. Which is what? 4. How many carbon do you have in total? 1, 2. Which is what? Which is 2. So this is the structural formula of what? Of ethene. Now, what will be the structural formula of propane? Propane is what? Is 3. If you put N to be equal to 3, that means you have what? C3H1. 2 times 3, 6. C3H6. That is the molecular formula of what? Propane. Now, if you want to draw the structural formula of propane, what you should put at the back of your mind is that you should have what? Double bond. Okay? How many carbon do you have? 3. First, stretch it out first. Then you can put double bond. You can put it here. You can put it here. You can put it anywhere. Okay? Now, let's put it here. Okay? Now, if you put it here now, okay, this is making it to be what? Propane. If there is nothing here like this, it will be what? Propane. Right? But if you have put the double bond, it is now propane. Are you getting it now? Now let's distribute the hydrogen. You distribute hydrogen in such a way that, okay, the number of hydrogen surrounding carbon, okay, agree with the number of bonds that will be surrounding the carbon. That is, each carbon will be surrounded by how many bonds? 4 bonds. So hydrogen could not be 1, or it could be what? 2. Now, here now, how many bonds will you need for it to be 4? 2. You can put 1 here, 1 here. Or you can put 1 here, 1 here. Anyhow. You can put 1 down, 1 up. Anyhow you want to do it. At least it must not be what? Be more than 4. Then you have hydrogen here. You have what? Hydrogen here. Okay, you don't have to put anything here again. This one, how many bonds does this one need for it to be 4? 1. It's 1. You have 3 already. 1, 2, 3. Then this one will complete to be what? 4. Then you have what? Hydrogen. This one now, how many bonds does it have already? Is what? 1. That means it needs what? 3 bonds now for it to complete 4. You have 1 here, 1 here, and what? And 1 here. Then you can now put hydrogen here, and hydrogen here. So this is what? This is propane. Propane. So if you want to do butane, what will you do? You just substitute N to be equal to what here? You substitute what here? 4. If you want to do butane, N is what? N is 4. That means butane will be what? C4H what? 2 times 4, 8. C4H8. That is the molecular formula. So if you want to draw the structural formula, then you follow that process. Under alkyne, what is the general formula of alkyne? Cn H2n minus 2. Okay? The first member under alkyne is also starting from n equal to what? N equal to 2, which is what? Ethyl. Okay? If you look at the last 3 letters, it's ending with what? YNE. So that means under what? Alkyne family. Alkyne group. Are we following? Are we following? Now, this is a time, if you want to know its molecular formula is corresponding to what? N to be equal to what? 2. Then you put what? C2H, 2 times 2, 4. 4 minus 2 will give you what? 2. You have what? C2H2. That is the molecular formula of what? Ethane. Now, let's now draw the structural formula of ethane. The structural formula of what? The structural formula of what? Now, what you should keep at the back of your mind is that you see this carbon, which is 2 carbons. Between them, you must have what? 3 bonds. Okay, you must have what? 3 bonds because of this YNE. Okay? Now, let's do it. Carbon, triple bond, carbon. Okay? This is what? Ethyl. Because of two carbon atoms and triple bond and 3 bonds. Because of these 3 bonds and 2 carbon, that made us to know that it is what? Ethyl. Okay? Now, how many hydrogen do you have? It's 2. These 2 hydrogen will distribute it around these carbons. Okay? So if you are distributing it, you distribute in such a way that the total number of bonds surrounding each carbon is not more than what? More than 4. Or let me just say it must be what? 4. Okay? This carbon here, how many bonds does it have already? 3. 1, 2, 3. That means in this one what? 1 more bond. You put the bond here. Then you put your hydrogen. Meaning that the total number of bonds surrounding carbon here is what? 4. Here too, how many bonds surrounding this carbon? Is 3 already. Then you need how many bonds? 1. That bond you can put it here, you can put it here, you can put it anyway. So if it is here now, you put what? You put hydrogen. Now this is now what? Ethyl. Is what? Is what? Ethyl. Now the second one, let's say it is what? Propyne. That is what? For n equal to what? N equal to 3. Is what? Propyne. Is what? Is what? Propyne. What makes propyne is that there are what? 3 bonds between what? Carbon to carbon atoms, and you must have 3 carbons. You must have what? 3 carbons because of this prop. The prop corresponds to n equal to what? N equal to 3. Correspond to what? N equal to 3, meaning that you have what? 3 carbons. And this one Ne, okay, made us to understand that there are 3 what? 3 bonds. Now, let's first draw out the what? The 3 carbons. Now, this one Ne now corresponds to what? Triple what? Bonds. I told you that triple bonds, you can put it here, you can put it here. If you are still dealing with general name, because you get to a point where you have to be conscious of where you are putting your bonds, your triple bond or your double bonds. You get to a point that you have to be conscious of where you are putting your what, where you are putting your double bond, or where you are putting your what, where you are putting your triple bonds. Okay, don't worry, we'll soon get there. When we get to IUPAC nomenclature, I will stress on what, I will stress on that. But for now, your bonds can be what, can be anywhere. It can be on the first carbon, it can be on the second, it can be on the third, it can be on the fourth. Okay? Then later, I'll make you to understand when, okay, to have, when you must have triple bond on a particular carbon. When you must have double bond on a particular carbon. But for now, it can be anywhere. Now, you have what? Triple bonds. Now, it's not left, okay, I've not written the general formula. The general formula is what? Since n is 3, you put what? C3, H, 2 times 3, 6. 6 minus 2, 4. It will be what? C3H4. Now, meaning that since you have 3 carbons, you need what? 4 hydrogen to surround the carbons. Okay? Now, before we distribute the hydrogen, let us fix bonds first. For this particular carbon, how many bonds is surrounding carbon here?
3.
It's 3. That means it needs 1 for you to complete the what? 4 bonds. Then you put what? Hydrogen. What about this place? It's complete already. So you don't have to put any bonds and you don't have to put any hydrogen. Then coming here, how many bonds is surrounding carbon here already? 1. That means it needs what? 3 bonds. You put 1 here, you put 1 here. You put 1 here. Then you can now distribute your what? Your hydrogen. Meaning that now you have 1, 2, 3, 4. 4 bonds surrounding the what? Surrounding the carbon. Say we want to get what? Butyne. What do I call it? Butyne. We are still under what? Alkyne. Butyne means what? N equal to what? N equal to 4. That is, you have how many carbons? 4 carbons. So if you substitute your N equal to 4 here, what do you have? You have C4, 2 times 4, 8. 8 minus 2. You have what? 8, 6. You have C4, 8, 6. Now, this is the molecular formula of what? Butyne. Now let's now draw the structural formula of what? Whataap. Okay, we have how many carbons? 4 carbons. Let's draw the 4 carbons first. You have these 4 carbons. And since you have one NE, that means there must be triple bonds, okay, between carbon to carbon atom. You have triple bonds here. I told you can put it here. Okay, let's put it here. 2, 3. Okay. Now we have what? How many hydrogen? 6 hydrogen. So we want this 6 hydrogen now. We want to distribute it around the what? Around these carbons. Okay. Here you have triple bond already. You have one bond already. Then surrounding with triple bonds. I mean 3 bonds. You have hydrogen. Here you have what? Hydrogen. How many bonds are surrounding this one? 4 already. So here is just 3. Then you need 1. You put your what? Hydrogen. Count the total number of hydrogen there. You will see that it is what? 6. 1, 2, 3, 4, 5, 6. And how many carbon? 4. 1, 2, 3, 4.